Now let's continue with the second question. The question says, if a, b, c are real numbers different than 0, which satisfy the condition a over 1 over a plus 1 over b plus 1 over c is equal to 1 over a plus b plus c, then it is 1 over a to the power of n plus 1 over b to the power of n plus 1 over c to the power of n is equal to 1 over a to the power of n plus b to the power of n plus c to the power of n for every odd number n. Prove it. Now, let's start with the given condition. 1 over a plus 1 over b plus 1 over c is equal to 1 over a plus b plus c. I will take this expression to the left side, and it will become 1 over a plus 1 over b plus 1 over c minus 1 over a plus b plus c is equal to 0. Now here I will equalize the denominators, and then I will get bc times a plus b plus c plus ac times a plus b plus c plus here ab times a plus b plus c and minus abc over abc times a plus b plus c. This one is equal to 0. Now I will take only the numerator to make some factorizations here. Let me write here. I will multiply one by one. I will get here abc plus b square c plus bc square plus a square c plus abc plus ac square here plus a square b ab square and plus abc and minus abc I have here. I didn't have a place to write. So plus abc minus abc will go from here. Now I will make some groups here and find the same terms. Firstly, I will take abc and bc square. So what is the common term here? It is bc. So I will have a plus c from here. Then I will take b square c and abc here. So it will be, what is the common term here? bc. And I will have b from here plus a from here. Then I have a square c, ac square. ac is common here, so I will have a plus c. And the last two terms, a square b plus ab square. So I have ab in common, so it will be a plus b. So as you see, we have a plus b or b plus a here, a plus b here, a plus c here. So I have two more same terms. If I will take a plus c in front of the parentheses here, I will have bc plus ac. From here I will take ab in front of the parentheses, and it will be bc plus ab from here. In the inside of the parenthesis here I have c in common, so if I will take c out of the parenthesis, I will get a plus c times a plus b times c plus here a plus b I have, and the common term in the parenthesis is b. So when I will take b out of the parenthesis, I will get a plus c times b. So as you see, we have a plus c times a plus b times a plus c. Again, I will take in front of the parenthesis, and we'll have here c plus b, so it will be, b plus c. So the factorization of the numerator will be in this way: a plus c times a plus b times b plus c. Now let's write in the question. It will become a plus c times a plus b times b plus c over ABC times a plus b plus c is equal to 0. Now from here we know that the denominator cannot be 0, so numerator it is 0. So from here I will get that a plus c is 0, or a plus b is 0, or b plus c is 0. So from here I will get a is equal to minus c, a is equal to minus b, or b is equal to minus c. Our question was to find 1 over n plus 1 over a to the power of n plus 1 over b to the power of n plus 1 over c to the power of n. And we know that from the question that n is an odd number. So if I will take the power of a to the n, it will be a to the power of n is equal to minus c to the power of n. Why? Because n is an odd number. It's given in the question. The same thing will be for the second one. A to the power of n will be minus b to the power of n, or b to the power of n will be minus c to the power of n. I will take the first one. If a to the power of n is equal to minus c to the power of n, what will be 1 over a to the power of n plus 1 over c to the power of n. When I will write instead of a to the power of n minus c to the power of n, it will become minus 1 over c to the power of n plus 1 over c to the power of n, which is 0. So from here, I can write that 1 over a to the power of n plus 1 over b to the power of n plus 1 over c to the power of n is equal to 1 over b to the power of n, because we found that 1 over a to the power of n plus 1 over c to the power of n is 0. So this sum will be equal to 1 over b to the power of n. Also, I can write that 1 over a to the power of n plus b to the power of n plus c to the power of n is equal to 1 over b to the power of n. Why? Because a to the power of n is minus c to the power of n. So these two will be 0. It will be b to the power of n. So from these two, I can write that 1 over a to the power of n plus 1 over b to the power of n plus 1 over c to the power of n is equal to 1 over a to the power of n plus b to the power of n plus c to the power of n. You can try for all three cases. You will get the same result. So we proved the expression that was asked to us. Second question.